Hey there everyone. In this video, we'll be looking at various kind of structural loads. We will try to add some basic frequently used loads and see how we can assign a phase and also assign some displacements to it. Let's start with our analysis. So let's say you are already in model, and then to get into an analysis, the first analysis, you just have to type model.analysis and 0. Let me assign it to a variable is a0. So a0 dot activate, it's a function, does not return anything. So you will see we are in analysis, the first analysis right now, and then we will create a fix support. Let's do it. So it will be a0 dot add fix support. It's a function, it returns a fix support. We have to assign it to some variable. So let's say fs, and let's assign a name. It will be test fix support. All right, so we have this fs dot name. So right now only thing you can assign is geometry. So let's say if I pass a name selection, it will automatically convert to name selection. You don't have to do anything right now. Let's assign it to a geometry. For that you need a selection info. So let me, it is a fixed support, right? So let me assign it to this face. So you can pass face id or based on your logic or whatever you can assign, but right now since I have already selected it, so let me assign this face to make it quick. It will be axt api dot, which is our entry point, and then selection manager dot current selection. So it will give you the face id, which is 11. And if you want to highlight, you can just do ext api dot selection manager dot maybe to show, it will be, no, this face dot id will show id, but to show highlight it, you can just, I missed what it was. I think it is current selection, new selection, and let's pass face. Oh, here it is. So it's a new selection. Okay, so I already have this face. So let's say fix support I had. So fs dot location, you have to pass the face, and you will see this face has been assigned. So this was on fixed support. Let's go, and the same for frictionless support also. So frictionless, you have only geometry, it will be the same. So let's assign, go to displacement. So we have displacement as let's assign it to a variable named as ds. So it will be a0 dot add displacement. So displacement has been added. As you see, we have defined by components and normal to. So normal to we will come back later, and uh, let's start with the face itself. So right now I will add displacement to this face. So let me assign that face again. Correct selection. Right now face, instead of 11 you will get 35. Okay, so this is good. And here I have displacement ds dot location is face. So we, right now it is free. Let's assign some input. So as you see, we have x, y, and z components. So here this magnitude will not work, and then we will revert to x component, right? So it will be ds dot x component dot input. As you know, it's a nested list. Let's find the 0. So right now it is two step. So you can give as one constant, or you can pass it variable. So let me just pass variable right now because I have that ready. So okay, so this is ds. So you will see you will have 2, and then you can pass the component output of it. So right now let me pass some units quantity. For example, in first step I will have 10 millimeter, and second step I have 20 millimeter. So you will see this is also assigned. Similarly, you can assign for y as y and z. Since I have it ready, let me copy, and once I paste, you will see everything has been assigned the same 10, 20, 10, 20. So what else we have? And then normal to, right? So let's go back to ds dot, this is defined by, I have components right now, and let's make it normal to. So it will be normal to a tangential. Yes. So right now you will see that it has come to a distance. It can be a constant or something. I have never used it, but yeah, it's the same thing. Like uh, ds dot distance. It is a field. Again, you have to pass the input. If it is a field, means you have to pass input. So it will be 1 second, and similarly for output. Right now it is free, so it's 0. That's why it's free. It's not 0. Sorry, 0 means I think 0 is free. Yeah. So similarly, you can add all the loads. Similarly, it will work for remote displacement as well. So it will not be a different thing. You will see remote displacement. You have x coordinate system. It's a quantity, and similarly y and rotation. Rotation will be in degrees. So instead of showing this one, let me choose uh, a rotational remote. Okay, let's do remote displacement as itself. Remote displacement is already created. Let me delete it, clear it out. So remote displacement, I will call it RD. RD will be A0 dot add remote displacement. Okay. So RD dot location, it's the same phase. All right. So since remote displacement has coordinates, you can just pass some other coordinate. So for example, y I already have as 26 millimeter. You can just move it to somewhere 35. That also you can do. But right now let's focus on this degree. So we have rd dot rotation x. So instead of x component, y component, z component, for rotation you will have rotation x, y, z. And similarly, you can just uh, input, we have, let me keep it constant this time, so 1 second. And instead of that, for output, let me, so in output we will pass 10 degree. So this is for the degree, and for radian you can pass rad. So here you will see it is constant since I have only 1 second, and then it will pass this rotation. So this was all about structural load, and in next video we will be looking at this was all about structural support. In next video we will be looking at structural loads. Thank you for watching. If you liked it, please hit subscribe and give a thumbs up. Thank you.